Today we're going to be talking about classifying, adding, and subtracting polynomials. All of what we do today should be reviewed from Algebra 1. If you have any questions, make sure that you are asking those and so that you are not falling behind. So the first thing that we're going to talk about is classifying polynomials. So the degree of a polynomial, let's start with the monomial. The degree of a monomial is the sum of the exponents of the variables. So when you're talking about just one variable, the degree would be the highest exponent. If you have more than one variable in a term, then you would add those exponents together, and that would give you the degree. So for example, if I have something like x squared, my highest degree is 2. If I have something like x squared, y squared, this is still one term, but here my degree would be 4. So this one has a degree of 2, while this monomial has a degree of 4. So if it's one variable, you just look at the exponent for that variable. And if the term has 2 variables, then you add their exponents together. So if we have a constant, remember a constant is just a number, no variable, then that has a degree of 0. Because we're always talking about the exponent of the variables. And so because this 3 does not have a variable, its degree is 0. Because 3 times x to the 0th power, remember anything to the 0th power is 1, so that would be 3 times 1, which is 3. So that is why a constant has a degree of 0. If something is linear, then it has a degree of 1. If we look at this expression right here, we have x plus 3. Here, x has an invisible exponent of 1. Remember, if the variable is not there, then it's 0. But if the variable is there, then the highest degree is 1. For a quadratic, this is what we spent all of Unit 1 talking about, quadratics. Your highest degree is 2. If you have a cubic function, then your highest degree is 3. A quartic function has a degree of 4. A quintic function has a degree of 5. And then everything after 5, we're just going to say 6th degree, 7th degree, 8th degree, 9th degree, and so on. So this polynomial right here has a degree of 6. And these just are saying that we continue this pattern on forever. So we can classify by the degree, but we can also classify by the number of terms. So if we look here, a monomial means that you have one term. So something that has one term is like 5xy. That is all one term. Remember, terms are separated by addition and subtraction symbols. A binomial has 2 terms. So something like x squared minus 9. This is a binomial because I have 2 terms. The terms are separated by the subtraction sign. A trinomial has 3 terms. So something like this would be considered a trinomial because I have 1, 2, 3 terms. And then anything with 4 or more terms doesn't have a fancy name. We just call it a polynomial. So if I had something like 8x to the 5th minus 5x to the 4th plus 6x cubed minus 2x plus 1, this would be a polynomial. Here I have 1, 2, 3, 4, 5 terms. Anything with 4 or more terms is a polynomial. So when we're talking about the degree, we were talking about the degree of a monomial. The degree of a polynomial is the degree of the term with the greatest degree. So that's why here I was just focusing on this term here because 2 has the highest degree, right? This variable has an exponent of 1, so this would be 2, this would be 1, and this is 0. The highest one is 2. Out of my terms here, I have 3, 2, 1, and 0. My highest degree is 3, so the degree of this polynomial is 3. Here, my highest degree is 4. This would be a degree of 0. So out of 4 and 0, 4 is our greatest degree. The degree of this term is 5, 3, 1, and 0. The highest one is 5. And then with this one, I have a degree of 6, degree of 4, and degree of 2. The highest one is 6. So it says, what is the degree of the following monomials? If I look at example A, we have 6. 6 is a constant, which means its degree is 0. A 0 is a constant. It's because I have no variable. For this monomial, we have 3x to the 5th power. My exponent is 5. 5 is quintic. And then for example C, I have negative 2xy squared. For this monomial, let's look at the variables. X has an exponent of 1. Remember, if it was 0, then it wouldn't be there. And then y has an exponent of 2. 1 plus 2 is 3. So my degree of this monomial is 3, making it cubic. What is the degree of the following polynomials? So make sure that they're in standard form when you're finding the degree. So here I have negative 4x to the 9th plus 5x squared plus 1. This is in standard form because my exponents go from highest to lowest. This term has a degree of 9. This term has a degree of 2, and this term has a degree of 1. The highest degree is 9. So this would be a 9th degree. For example B, I have, 7x to the 4th minus x cubed plus 5x squared minus 9x plus 4. This is in standard form because my exponents go from highest to lowest. This is of degree 4, degree 3, degree 2, degree 1, degree 0. My highest exponent is 4. So when it's 4, that means that it is quartic. It says classify by the degree and the number of terms. So we're going to be classifying by the degree and by how many terms they have. So in example 1, I have 5x squared plus 9x. Or sorry, not 9x, x to the 9th power. Here, my highest exponent is 9. If it helps you, rewrite this in standard form. So I have x to the 9th plus 5x squared. My highest degree is 9. So this is a 9th degree binomial. This is a binomial because it has 1, 2 terms. For example 2, I have negative 12x y to the 5th minus 7x squared. So for this first term, I have x to the power of 1. 1 plus 5 is 6. And this one has a degree of 2. The highest one is 6. So this one would be a 6th degree binomial. Again, this is a binomial because I have 1, 2 terms. On example 3, I have negative 15. Negative 15 does not have a variable, so that makes this a constant. And then I just have 1 term, So this is a constant monomial. The next two problems say simplify, write each polynomial in standard form, and then classify by the degree and the number of terms. If I look at example 4, I can see that I am adding. When you are adding, you are combining like terms. I can see that 3x cubed doesn't have a like term, so I'm just going to go ahead and bring that one down. 12x squared plus 5x squared is 17x squared. 9x minus 6x is 3x. And 6 plus 7 is 13. So this is written in standard form because my exponents go from highest to lowest. My highest degree is 3. That makes this a cubic. And then I have 1, 2, 3, 4 terms, so it is a polynomial. On example 5, again, I am adding. So I'm going to have 2x minus 2x is 0. Negative 7x squared plus x squared is negative 6x squared. And then 1 doesn't have a like term, so I'm going to bring that down. This is written in standard form. My highest exponent is 2, so that makes this quadratic. And then I have 1, 2 terms, so this is a quadratic binomial. Simplify, write each polynomial in standard form and classify by the degree and the number of terms. On example 6, I can see that we are subtracting. So remember, it is very important that you distribute that negative to everything in the second set of parentheses. Your first term is your first polynomial is gonna come down. Negative 1 times negative 6x squared is positive 6x squared. Negative 1 times negative 2x is positive 2x. And negative 1 times 1 is negative 1. Now that I have distributed that negative, I can go ahead and combine like terms. 2 minus 1 is 1. 9x squared plus 6x squared is 15x squared. And 2x doesn't have a like term, so I'm going to bring that down. This is not in standard form. So I need to go ahead and write it in standard form because they ask me to do so. So my term with the highest exponent comes first, then the next highest, and then the next one. So this is my answer in standard form. The highest degree is 2, so that makes this quadratic. And then I have 1, 2, 3 terms, so this is a quadratic trinomial. On example 7, again, I can see that I am subtracting, so I need to go ahead and distribute. I'm going to go ahead and bring down that first polynomial. So I have 6x cubed plus 3x squared plus 2x squared plus 9. And then over here, I'm going to distribute, so I'll have negative 4x to the 4th times negative 8x squared plus 5. So now I'm going to go ahead and combine like terms. 6x cubed doesn't have a like term, so I'm going to bring that one down. 3x squared plus 2x squared minus 8x squared. Let me see, that gives me 5 minus 8 is negative 3x squared. 9 plus 5 is 14. And then I'm going to bring down my negative 4x to the 4th. I need to write this in standard form. So my highest exponent goes first, and then we go in descending order from there. So this is my answer. My highest exponent is 4. So that makes this quartic. And then I have 4 terms, so this would be a quartic polynomial. For example 8, it says a rectangle has a perimeter of 6x cubed plus 9x squared minus 10x plus 5 and a length of x. Find the width of the rectangle. So here is my rectangle. Perimeter is when you add all of the outsides. Right now, I know that the length is x. In a rectangle, this side is the same as this side. And this side is the same as this side. So if I know the total is this, then I can find the missing side length, right? Because we know that perimeter is 2 times the length plus 2 times the width. They tell us that the perimeter is 6x cubed plus 9x squared minus 10x plus 5. And they also tell me the length is x. So I can just solve this equation for w to find the width, right? So I'll have 6x cubed plus 9x squared minus 10x plus 5 equals 2 times x is 2x. So I want to get 2w alone, so I need to move 2x to the other side. It's positive, so to move it to the other side, I'll subtract it. So I'll have 6x cubed plus 9x squared minus 12x plus 5 equals 2w. And then I want to get w alone. Well, w is being multiplied by 2, so I'm just going to go ahead and divide both sides by 2. So my width is 6x cubed minus 9x squared minus 12x plus 5 divided by 2. That is my answer. On example 9, it says an engineer is creating a solar farm. The solar farm has 4 small panels, 3 medium panels, and 32 large panels. The area for each section is given below. What is the total area of the farm's solar panels? So we know that the small solar area is 4x squared plus 24x. The medium solar panel area is 33x squared plus 272x. And the large solar panel area is 32x cubed plus 384x. So if I know the areas of each part, I can just add them together and find the area of the whole thing. So we're going to do the area of the small plus the area of the medium plus the area of the large to give us a total. So small is 4x squared plus 24x. Medium is 33x squared plus 272x. And the large is 32x cubed plus 384x. So now I can combine like terms. I can see that this is my highest degree, so I'm going to go ahead and write that first since it doesn't have any like terms. 4x squared plus 33x squared is 37x squared. And then 24x plus 272x plus 384x. Let me just go ahead and grab my calculator for that one. So 24 plus 272 plus 384 is 680x. That would be the total area.